This lesson is on section 9.7, experimental and theoretical probability. Now, experimental probability is found using frequencies obtained in an experiment or in a game, and a theoretical probability is the expected probability of an event occurring. So my first example is I have a chart that shows candidates that are running for, let's just say, student council, and the number of people that voted for them. So the question is, what's the theoretical probability of, let's say, John winning? And what's the experimental probability of John winning? Okay, so when I think of theoretical probability, I'm thinking, in theory, when what is he expected to win? So there's 3 people running. So John has 1 out of 3 chance of winning. So we can say the fraction is 1/3, or we can say about 33% chance of winning because he's 1 out of 3 candidates running. 1 out of 3. However, experimentally, let's see if that was the case. Well, it looks like, let's count the number of voters that actually voted for these candidates. So we have 75, 67, and 83. So if I add 75 plus 67 plus 83, I'm going to get 225 voters. Well, experimentally, there's only 75 out of 225 people that voted for him. So my fraction, and I'm just going to put it at the top here, 75 out of 225 voters. And then when I reduce my fraction of 75 over 25, I can divide them both by 75 to get my fraction 1/3. So in theory, he was supposed to get 33% of the votes, and experimentally, he did get actually 1/3 or 33% of the votes. So in this case, the theoretical probability was the same as the experimental probability. Sometimes it doesn't work that way, but a lot of kids get mixed up on what's the difference between theoretical and experimental. Like, theoretical is what you expect to happen, and experimental probability means what actually does happen. So we expected John to get 33% of the votes because he was 1 out of 3 candidates, and in actuality he did get 33% of the votes because he had 75 out of 225 votes. So my next example is I have a chart, and let's say I roll a number cube, and my numbers are up here. So this just shows I have the number, this shows I have the number 1, 2, 3, 4, 5, and 6. And then at the bottom row shows the number of times I roll that number. So for example, if I look right here, I have the number 1 is rolled twice. The number 2 is rolled 2 times. The number 3 is rolled 5 times. The number 4 is rolled 1 time. The number 5 is rolled 5 times. And the number 6 is rolled 3 times. So my question is, find the experimental probability and theoretical probability of rolling a 2. Okay, so if we start with experimental, remember, experimental probability is what actually happened. So I'm going to look at this column right here. So it looks like that I rolled a 2 times. So my experimental probability would be 2 out of the total number of times that I rolled the dice. So now what I have to do is I have to count how many times I actually rolled. So I'm going to add 2 plus 2 plus 5 plus 1 plus 5 plus 3. So 2 plus 2 is 4, plus 5 is 9, plus 1 is 10, plus 15, or plus 5 is 15, plus 3 is 18. So my experimental probability was 2 out of 18 times, and that reduces to 1/9. So my experimental probability is 1/9. Well, in theory, though, my theoretical probability is I have 1, 2, 3, 4, 5, 6 different faces on my dice. So you would think that I would get a 2 1 out of 6 times. So in theory, my probability is 1/6. And that brings us to the end of my lesson.